So before we begin composition of functions, let's remind ourselves from last week where we studied combination of functions. So with regards to combination of functions, all right, in that section, one of the things you saw was that if you add two functions, and this is a notation you use, which is what you would see on your test today, what is that the same as? F plus G evaluated at X. What's that the same as? Plus G of X. Okay, good. So if you have the difference, so if you had F minus G at X, then by definition, what is that?
F of X minus G of X.
Okay, and then you saw product. So if you have F times G at X, then that would be F of X times G of X. And then the quotient, where you had F divided by G at X, then that would be F of X divided by G of X. So now remember, the difference and the quotient are not commutative, so the order matters. So if F is listed first, then F of X has to be listed first here. The same thing for quotient. If your function F is in the numerator, then you got to put in your numerator here. Okay? So if this is G divided by F, then you would have what function over here? G of X divided by F of X. Okay. All right. So let's suppose that F of X is 5x minus 9, and G of X is 7x plus 2. So we're dealing with just two linear functions. And one of the things you have to be able to do, and you're going to see this again when we talk about composition of functions, which will be on test 4. But one of the things you have to be able to do with combination of functions is something like this. Evaluate, let's say, G minus F at negative 2. So on your test today, how would you deal with that? Evaluate G minus F at negative 2. Well, first of all, you need to rewrite it. How would you rewrite this? G of negative 2 minus F of negative 2. All right, that's what you have to do first. So, and basically you're using these definitions right here. So that would be G of negative 2 minus F of negative 2. All right, and then you do each part. So you find G of negative 2, then you find F of negative 2. All right, to find G of negative 2, so you go off to the side and you do some work. So to find G of negative 2, wherever, you got to go to which function to do that one? G function. So wherever you see the variable x, you plug in negative 2. So I get 7 times negative 2 plus 2. So that's negative 14 plus 2, which is negative 12. So that's G of negative 2. You got to subtract, though. Remember, you're subtracting, so you got to subtract F of negative 2. So I got to find what F of negative 2 is. So remember, that means I go to which function now? F of X, and where we see the variable X, I plug in negative 2. So I get 5 times negative 2 minus 9. So that's negative 10 and a negative 9, which is a negative 19. So that becomes this right here. But look what you have. You have negative 12 subtract a negative 2. So if I change this to an addition problem, that becomes negative 12 plus a positive 19. And so what is the answer? 7? So you get 7. Now remember, we talked about this also. So if I evaluate this function at a number, I better end up with a number as the answer. So for example, if I had number 2, and let's suppose in number 2, I want to find F times G at X. All right, well, by definition, what's F times G at X? F of X times G of X. All right, so that's what that means. F of X times G of X. And so here, I'm doing what to those two functions? What's the operation? Multiplication. All right, now remember, you got to put those in parentheses, though, because you're multiplying these two functions. So my function f is 5x minus 9, and my function g is 7x plus 2. And so if I want to multiply that out, then I have to use what method? Okay, I could use a distributive property, or I can use the FOIL method. So if I FOIL, 5x times 7x is 35x squared. What's the outer? 10x. What's the inner? Negative 64x, is that correct?
Yes.
9 times 7 is 6. Oh, I'm sorry, 63, excuse me. 63. And then negative 9 times 2, negative 18. Combine like terms, you get 35x squared minus 53x minus 18.
Yep.
All right, that's what you put in the blank. So if I evaluate at a variable, then I'm going to end up with a variable expression as the answer. Now, one of the things you also talked about was this. What if I asked you to find the domain of f times g at x? Well, what's the domain of f times g at x? All right, so you're saying it's all real numbers? Why is the domain? Now remember, when I say this, I mean this right here, right? Okay, so which equals this. All right, but you're saying the domain of this is all real numbers. Why is it all real numbers? That we talked about that. You got to know that.
Because it's only raised to the second.
That's not why. Why is the domain of this all real numbers? There's one thing you learned, because it's a polynomial function. Good. She said because it was raised to the second power. Well, it could have been raised to the fifth power. Could have been raised to the 10th power, right? So because you have to know, because it's a polynomial function. So remember, all polynomial functions is defined for everything. But remember, you got to put it as an interval, so it'll be negative infinity to infinity. Okay? All right, and then real quick, what if you had number 3? What if we had this for number 3? You had, let's see, you had g of x divided by f of x. All right, well, what is g of x in this case? No, but what is g of x? 7x plus 2. What's f of x? 5x plus 9. So your answer would be 7x plus 2 divided by 5x minus 9, right? There's really nothing to do. But what if I said find the domain of g of x divided by f of x? Okay, but why would you do that? Why is it that you didn't do it here, but you did? Say it again? Because it's a rational function. Good. So all rational functions are not defined when the denominator is 0. So you got to find out where this denominator is 0. So you said that denominator equals 0. So when I said that equal to 0, I get this linear equation, and so I get x to be 9/5. Now what I found was that 9/5 makes this fraction undefined. So this rational function is defined for all real numbers except which one? Positive 9/5. So remember what we did was we put that in a number line, and we crossed it out, and so you're going to end up with how many intervals? 2. And so your answer would be negative infinity to 9/5 union 9/5 to infinity. Okay?
And we don't use brackets because 9/5 is not.
Because if you use brackets, it means that you can include 9/5. But remember, 9/5 is not part of the domain, because we're talking about domain here. Okay, now one other thing that we need to remember how to do before we talk about composition of functions is this. So suppose this time that that f of x is x squared plus, let's make it 2x squared plus 7x minus 5. and you want to find f of x minus 6. So if you have this in your test today, what would you do? Where we see the variable x in your function f, you're going to substitute x minus 6. So basically you're going to say this right here is going to equal 2 times, in parentheses, what do I put? X minus 6, but that's being squared, plus 7 times x minus 6 minus 5. All right, now you got to get rid of these parentheses, so how are you going to do that? Okay, use the order of operations, so I'm going to do parentheses, but there's really nothing to do inside these parentheses. X minus 6 is still x minus 6, but what's the next part to do? Using order of operations. Exponents, right? Please excuse my dear Aunt Sally. So exponents. Now, are you going to multiply first, or are you going to square first? You're going to square first. So off to the side, you figure that out. X minus 6 times itself, right? So you can either use a distributive property or you can FOIL. X times x is x squared. The outer and the inner have to be the same because they're it's the binomial times itself. So when I add the outer and inner, I get a negative 12x, right?
Yes.
And then a negative 6 times a negative 6 is a positive 36. Now all I found was this part here. But that's being multiplied by 2. All right, now let's go ahead and distribute this. So that's going to be 7x minus 42, and then minus 5. Now remember, you couldn't distribute first here because see how I was able to distribute here, but I couldn't do it here? You can only distribute if the exponent up here is 1. That's not a 1, that's a 2. So you have to FOIL first, and now that exponent's a 1. And so I can distribute now. So I get 2x squared minus 24x plus 72 plus 7x minus 42 minus 5. And so the answer becomes 2x squared. All right, a negative 24x and a positive 7x is negative 17x. All right, now use your calculator if you need to. A positive 72 and a negative 42 is 30, is that right? And then 30 minus 5 is 25. Okay. All right, now, so that's going to take us to composition of functions. So what we did is on your test. So that's basically a quick review of that part of your test. So let's talk about composition of functions. Composition of functions. So for that part, let's look at this idea. Okay. Suppose that f of x is x squared. Okay? Suppose that f of x is x squared. And suppose that g of x is x minus 5. G of x is x minus 5. Okay? All right, so f of x is x squared. G of x is x minus 5. And let's suppose I wanted to find f of x minus 5. All right, well, we just did something like that. We did a harder one a while ago. So to find f of x minus 5, you would go to your function f, and where we see the variable, you would plug in what? X minus 5. That's what that means, right? So it'll be x minus 5 squared. Y'all agree? All right, and then you work it out. Okay, what I did, though, is this. So see how I said I wanted to find f of x minus 5? Now watch carefully what I'm about to say. All right. Do you see that this x minus 5 right here is really what function? No, what function is x minus 5? No, f of x is x squared. What function is x minus 5? G of x.
Oh.
There's only two functions there, guys.
Okay.
There are only two functions, f of x and g of x. Is that really the issue? I'm hoping that's the issue and nothing else. So f of x is x squared, g of x is x minus 5, right? So when I asked you, I said, what function is x minus 5? That was g of x. So I want you to notice this. You see this right here? What I did was I took the function g of x, which is this right here, right? And I plugged g of x into f of x. That's what I did. So I took g of x, plugged it into f of x. So when I did this problem right here, I was really doing composition of functions. So I was taking a function here, which just could have been a function, and I plugged it into another function. So this is where I take a function, plug into another function. That is called composition of functions. So composition of functions is where you take a function and put it inside of another function. Okay, and put it inside of another function. So this is how this really looked right here. You see where I said find f of x minus 5? It is very important that you see I could have also said this. I could have said find f of, and then what's x minus 5 the same as? G of x. That's how it's going to look. That's how it looks. So you see you have two functions. You have the function f and you have the function what? G. Don't confuse that with this. This is not putting a function inside of another, because you don't see that anywhere here. You see where I'm either adding two functions, or I am subtracting two functions, or I am multiplying two functions, or I'm dividing two functions. That's called combining functions. That's what that is. Composition of functions is where I take a function and put it inside of another. Yes?
Yeah, because when I was doing the combination,
Uh-huh.
I wanted to do this.
No. That's combination. That's composition. That's where you take a function, put it inside of another. Here, at any point, did you take this and put it inside this? No. All you did was either add them, right?
Right.
Or you subtracted them from each other, or you multiplied them, or you divided them. At no point did you say find f of 7x plus 2. Okay? So combination is where you add, subtract, multiply, divide. Composition is where you take a function, put inside of another, which you've been doing. You just didn't know that you were taking a function, put inside of another. But that's how it looks, though. That's that new notation you got to be aware of. Okay, now here's some other notation you have to be aware of with this. Okay, listen carefully. So notation. And we're going to work some problems with this. It's not difficult. Notation. Okay, so it's going to look like this. F, so the symbol for saying I am composing a function inside of another, you see how I took a function g and put it inside f? This says I am composing functions f and g. That's what that says. I am composing f and g. I'm not combining f and g. Combining uses which operations? Addition, subtraction, multiplication, and division. That's not what this is. This is just taking a function, putting inside of another. That's composition. Now here's your notation though. All right, so you can see it written like this. F, now the symbol for composing is an open circle. Looks like this. So this says I'm composing which functions? f and g. This says, if you have this says you're doing what? Multiplied. This is multiplication. This is what? Composition. Open circle is composition. Closed circle with a dot means multiplication. Okay? Now, here's how it's going to look, though. F composed with G, add X. Notice the difference. Compare these two. So if I had multiplication, we all know what this is right here. What's this right here that I'm pointing to? F of X times G of X. See how that looks? All right, look how this will look now. This is composition. Whatever's listed first goes on the outside. So F is listed first. So that says I'm taking G and putting it inside of what? F. So it looks like this. So this right here means F. This right here means F of G of X. That's what that means. That's how you read it. F of G of X. F of G of X. If I had it the other way around, then that would be written as what? G of F of X. Okay? All right. That's the only definition. All right, so let's look at the problems. Okay, so I'm going to have 3 functions listed. So let's suppose f of x is 3x minus 1. G of x is 2x plus 5. And h of x is negative x squared plus 7x minus 2. All right, so write those 3 down. So f of x is 3x minus 1. G of x is 2x plus 5. And h of x is negative x squared plus 7x minus 2. Okay? All right, number 1. All right, what if you had this? What if you had f minus g at x? First of all, remember we talked about combining functions and we talked about composing functions. Which one's this one? Combining. All right, so how would you do this? No. What would you write first? F of x minus g of x. That's what you would write first. Now you do the substitution. So what's f of x? 3x minus 1. Now you're subtracting. If I'm subtracting, what else should I do? Put in parentheses. What goes inside the parentheses? 2x plus 5. All right, now what's the next step? Get rid of the parentheses. So I get 3x minus 1 minus 2x and then minus 5. So what is the answer? X minus 6? So in the blank you would say you would say f minus g at x is, and in the blank you would say x minus 6. Okay? Number 2. Let's suppose this time I wanted to find this. F composed with g at x. F composed with g at x. Now, I already said it for you. It's composition this time, right? All right, you got to know your definition. Now, this number 2 is on test 4. So on test 4, how would you do number 2? How would you rewrite it first? F of g of x. That's what you would say. All right, now listen carefully to what I'm about to say. So you're going to do the inside first, the one that's inside the outermost parentheses. See that g of x? So you're going to replace g of x with what it is. What is g of x? 2x plus 5. So in place of g of x, you're going to say 2x plus 5. So that becomes f of what? Yeah, and then the rest is what you would see on tests today. So on the test today, how would you find f of 2x plus 5? You go to your function f, and wherever you see the variable x, what do you substitute? 2x plus 5. So remember, f of x is this. Let me go ahead and rewrite it here. So wherever you see the variable x here, you're going to substitute 2x plus 5. So I get 3 times what? 2x plus 5, and then subtract 1. What's the next step? Distribute. So it becomes 6x plus 30. I'm sorry, 15 minus 1. So what's the answer? 6x plus 14. So f composed with g at x is 6x plus 14. That will be the answer. Now what if it had this? Let's say number 3. All right, so number 3, suppose it had g of h of x. G of h of x. Now first of all, is this a combination problem or is this a composition problem, number 3? Composition, because you're taking a function, putting it inside of another. It's just that it's not written like this. It's automatically written in terms of the definition. But which functions am I dealing with here? Which two of these functions am I looking at? G and h. Okay. Which function is inside of the other? H. H is inside of G. So I got to do this one first. I got to do H first. So H is this right here, right? All right. So in place of H of x, I'm going to substitute negative x squared plus 7x minus 2. Okay? Let's see what I did. So H of x is this, right? And then the rest is on today's test. So how would you do this on today's test? How would you find g of this expression? So you go to your function g, and g is this right here. This is g. So where we see the variable x, what do you substitute? Negative x squared plus 7x minus 2. So it becomes 2 times what? Plus 7x minus 2, and then plus what? 5. Okay, what's the next step? Distribute. And so the answer is going to be negative 2x squared plus 14x minus 4. Oops. Okay, so let me go ahead and do that here. I said the answer is going to be that, but I forgot that I'm also adding what? 5. So that's negative 2x squared plus 14x minus 4 plus 5. So the answer is going to be negative 2x squared plus 14x plus what? Plus 1. You agree? Okay. All right, number 4. Suppose you had this number 4. Suppose number 4, you want to find h of g of 3. H of g of 3. Now the work you need to be able to do for today's test. Okay? So for example, what is it that I've got to look at first here? G of 3. So I got to find g of 3, right? Just like we did here, I said we got to find h of x first. Well, what was h of x? Well, this expression here. So here I got to find what first? G of 3. Now that's on today's test. So how do you find g of 3? In the function g, though, right? So g of x is this. So we see the variable x, you're going to substitute 3. So that's 2 times 3 plus 5, which is 6 plus 5, which is 11. Now remember, all I found was g of 3, right? So that means that this is, instead of rewriting as g of 3, I can say g of 3 is now what? 11. So I got to find h of 11. That's on today's test. How do you find h of 11? You go to your function h, which I'm going to go ahead and rewrite it. It's just right here. So h of x is negative x squared plus 7x minus 2. So you go to your function h, and where we see the variable, what do you substitute? 11. All right, you got to be careful because that's negative x squared. So that becomes negative. Now, what's being squared when I have it as negative x squared that looks like this? No, but what's being squared? Is it x or negative x? X. Okay, so I got to put only what in parentheses? 11. Okay. Plus 7 times 11, and then plus, I'm sorry, minus 2, right? Okay, order of operations. What's 11 times itself? What is it, 22? 121, right?
21. I'm only halfway through. I need 5 more minutes.
All right, negative 121. And then 7 times 11 is 77. Minus 2? All right, you have access to your calculator. What's a negative 121 plus 77?
Is it positive?
What now?
Is it positive one too?
No, because the only thing being squared is 11.
Oh,
So what's negative 121 plus 77? Negative what? 44? And what's the negative 44 and negative 2? Right. So then you would say in the blank, you would say h of g of 3 is equal to what? Negative 46. All right. So in order to do these problems, you have to remember some things you've had. All right. Now, what if I had number 5? What if I had let's say h composed with, let's say, f, h composed with f at negative 3 this time. H composed with f at negative 3. Now, I want you to see the relation between 4 and 5. You're going to see that 4 is the same thing as 5. I mean, it's not the same number and the same functions, but it's the same idea. You see, number 4 was already written in terms of the definition, where it had the function g already listed inside of the other. Here, I have it written as that open circle. All right, but definition, though, what is this? H of f of negative 3. All right, and now see, it looks like number 4. All right, so remember what we just did. How do you find, well, what do you have to find first? F of negative 3, which you got to find first. You got to find this first. So you got to find that inside function first. All right, find f of negative 3. So I got to go to my function f, and f of x was this. And so wherever I saw the variable x, what did I substitute? Negative 3. So I get 3 times negative 3 minus 1. So that's negative 9 minus 1, which is negative 10. So that's f of negative 3. So is that the answer?
No.
No, what must I do with that negative 10?
Plug that into your H.
Right. So in terms of your progression here, what you found was only this part here. So now we've got to find h of what? Negative 10. And so now I go to my function h, which was this, negative x squared plus 7x minus 2. So I go to my function h, and wherever I see the variable this time, what do I substitute? Negative 10. All right, but remember that becomes right here, that's going to become negative, and what's being squared? Negative 10 plus 7 times negative 10 minus 2.
Plus 2?
No, minus 2.
Oh, minus 2.
So what's a negative 10 squared? 100. So this becomes what? Negative 100. Right? Negative 10 squared is a positive 100. This becomes a negative 1 because there's negative on the outside. Just like over here. Y'all agree, right? Y'all didn't have any issues here. Why are you having an issue here? Well, what's being squared? 11. Because there's negative right here. You're saying whatever that is going to be negative. So on the outside, you're not squaring negative 11, you're squaring 11. Okay. Times itself. What's negative 10 times itself? 100. So that becomes negative 100.
So we don't make it a pot. I want to, since it's negative, I want to make it a pot.
We talked about this right here.
Well, technically you do.
No, you don't. No, you don't, because if you say that becomes a positive 10, hold on, if you say that becomes a positive 10, then 10 squared is 100. The answer is negative 100.
Yeah, but you just drop your negative down and then negative.
No, she's saying she wants to make this a positive 10
Oh.
and then square it. We talked about the factor a while ago, guys, that and let me go ahead and say, oh, it's right here. Can I distribute this?
No,
No, because why?
we have exponents.
Because your exponent is not a 1.
Right.
So I cannot say the opposite of negative 10 here because I got to do this first.
Right, okay.
Okay? So you got to do this first. You got to square first. Okay. All right. So negative 100 minus 70 minus 2. So it becomes negative 170 and a negative 2, which gives me what answer? Negative 172. Okay? All right. So that's going to take you, as far as composition, we're done. So we looked at composition and combination of functions. All right, so that's the end of that part.